This video will demonstrate the investigation from Unit 6, Activity 1. Here we have the Geometers Sketchpad investigation. Note that we have the measure of the x-coordinate of A, the y-coordinate of A, the hypotenuse of our triangle, and the measure of angle ABC. So if I move point A, notice that the coordinates of point A move as well as the angle. Okay. And I can change the size of the triangle by moving this point if I wish. So notice that the coordinates of A change again, but the hypotenuse this time also changes. So now the investigation asks us to answer a few questions. The first of all is, in what quadrants is the x-coordinate of point A positive? So if I move A around the grid, around the Cartesian plane, where do I see the x-coordinates being positive? Well, I can see that they're positive in the first quadrant and the fourth quadrant. They're negative in the second and the third quadrant. The y-coordinates of A will be positive in the first and the second quadrant, but negative in the third and fourth. Those are going to be important when we try to connect the coordinates of these points to the sine and cosine and tangent ratios. So let's move on to the next part of the investigation. We're asked to try to build a 30-degree angle. So I'm going to move point A here until it's about 30 degrees. It'll take a little bit of, there we go. We have 30 degrees. And now determine the ratio of the opposite over the hypotenuse, which is the sine ratio. So I'm going to take the opposite and divide it by the hypotenuse. So first of all, what is the opposite in my triangle ABC? The opposite is side AC. That side is actually determined by the height of this point, how high it is, and that's actually the y-coordinate of A. So this side length is 3.34. The hypotenuse, of course, is AB. So I can do a calculation on a piece of paper, or I can actually use GSP to actually calculate that. I'm going to go to the number menu, and there's a calculate option. The opposite side, again, is the y-coordinate, and I will divide that by the hypotenuse. And there we have it. So the ratio of the opposite over the hypotenuse, which is the sine ratio, is about 0.5. And again, that was determined by the y-coordinate. Now, the next question asks me to try to find another location where I can move A where this ratio will be the same. It'll be 0.5. So where could I move this triangle on my grid so that I end up with this exact same ratio? Now, the problem here is that I need this to be positive. It has to be 0.5. So I need it to have the exact same y-coordinate that it currently has, which is 3.34. So where else will I have a positive y-coordinate? And so that connects it back to the question we just answered about when is the x-coordinate positive and when will the y-coordinate be positive. So I know that the y-coordinate will be positive in the first and second quadrant. So I'm going to try to move point A into the second quadrant and try to get the exact same ratio, 0.5. I'm now in the second quadrant. Note that the ratio here is 0.98. I want to try to get that to be 0.5. We're almost there. And there we have it. The ratio of the opposite over the hypotenuse is 0.5. Note that the y-coordinate, we're off by a little bit. It's not exactly the same as it was on the other side, and that's because of rounding errors here. But the y-coordinate is positive. And again, the key here is that we're trying to stress that the y-coordinate is defining the sine ratio, since the y-coordinate provides us that opposite side in this triangle. The next question asks us to find the angle in standard position and the related acute angle. It's actually easier to answer the second of these questions. What is the related acute angle? As you can see here, the measure of angle ABC is 29.9 degrees. It's about 30 degrees. It's the exact same it was in the first quadrant. What is the angle in standard position? Remember, an angle in standard position is measured from the positive x-axis to the terminal arm of that angle. So how much is this angle here? Well, we know that this angle is 30 degrees, the measure of angle ABC, and we know that the full line is 180. So 180 take away 30 degrees will give us this angle right here. I can place a point on the x-axis and actually measure that if I want. So I'm going to measure A, B, and this point I just dropped on the x-axis. I'm going to go to measure angle, and you can see it's about 150. So the angle in standard position is 150 degrees. The related acute angle is 30 degrees. But the key connection here is that I now have the exact same sine ratio for two different angles. Sine 30 degrees gave me this measure of about 0.5, and sine 150 degrees gives me the exact same measure of 0.5, because again it was defined by that y coordinate, which is still positive. You're going to try to do the same thing for the cosine and tangent ratio and find where else can you get the exact same answer for an angle that's defined in the first quadrant. Where else on the grid can you get the exact same answer?